Hey guys, how's everything going? This is JSer. In this video, let's solve another problem from LeetCode. It's 1198. Find smallest common element in all rows. Given a matrix mat where every row is sorted strictly increasing order, so there is no duplicating each row, return the smallest common element in all rows. If there's no common element, return -1. So like this, so 5 is the minimum smallest number in each row. Well, I kind of I have done similar questions like the row matrix problem, like find the top k element among a bunch of arrays, stuff like that. So here in this problem, let's think of a simpler case. Suppose the row only 2 rows, right? Suppose there's only 2 rows. How could we solve this problem elegantly? Okay, if there is 2 rows, you need to find the smallest common element in these 2 rows. We could just do with the 2 pointers, right? We just check the head, and if this is not smaller, then we go to the next one. If they are the same, so this is the smallest common element, and we're done. So we could easily solve this with 2. But if there are more rows, how should we do it? Well, we just first we get the duplicates in these 2 rows, right? In this case, we find 2, but actually 2 might not be in the third row. So we need to find all the duplicates. So I mean, the idea is just to find duplicates in 2 rows and do this all over again and again. This is kind of like okay, we get these 2 and get the duplicates and move it back, right? So that we only have 1 array now. Originally we have n array, and now we get n-1 array until we have only 1 array. That would be the only array of duplicates in all array, and then we just return the first element and it would be done. So what's the time complexity of this approach is that we need to actually obviously traverse through all the elements here, right? And all the elements here to tackle 1 round, and we get the duplicates, and then we need to do this again to all the for the next array. So obviously we actually have to, for each item it will be traversed twice, so I would say it's n, suppose the n array m, yeah, it's generally linear time for all the elements count. So this is it. Let's do it. So first we create a function called find duplicate, which accepts array 1 and array 2. In this function, we hold all the duplicates in the array and create a cursor. Zero, let j equal 0, while I smaller than ar1.length, j smaller than ar2.length. If they are the same, this is one of the duplicates, right? So we push them into the result and increment both the cursor. If the first one is smaller than the next one, if this first one is smaller than the second one, then we move the first one to the next index. In the other case, we just move the j to the next. And after this, we return a result, right? And now we have this atomic function that will reduce 1 array for us. We would just then reduce all the array in the while loop. So when there is more than one array, we could keep it could go from left to right, but the order doesn't matter. We just use pop for better performance. So top 1 equals mat pop, const top 2 equals mat pop, right? And then we push, find the duplicates, top 1 and top 2. Yeah, and then there will be only one array left. So we return the first array, the first item. If the reason is undefined, then we return -1. Submit, run the code. Pretty cool. Let's submit. Yeah. So this is our approach. Pretty simple, I would say. Okay, actually we could solve this problem in another priority queue fashion I can think of. Well, it's just it will be more complicated than this one, so I'll keep in this approach. So that's it. Hope it helps. See you next time. Bye bye.